All right, so what is self-metathesis? Self-metathesis is when an alkane reacts with itself via alkene or olefin metathesis. So in the previous video, I talked about reacting these two alkenes together. So how would you figure out self-metathesis? Well, self-metathesis, you would do a Punnett square. But for your Punnett square, you would just list the compound on both sides. So let's redraw Punnett square. So we got the left and the right. And we would just do the same thing here, the left and the right. And we would go through the Punnett square again. And again, keep in mind you're going to get both cis and trans forms if they are formed. And that's the product of self-metathesis. Instead of having two different alkenes on top and side, you end up having the same alkene on both sides. But this is kind of a complication if you get into like a mixed alkene metathesis. So if you have a metathesis reaction where there are two different alkenes in roughly equal amounts, yes, you will get the metathesis products of both of them reacting with each other. You're also going to get the metathesis products of them reacting with themselves. You can't stop this in a reactor. And so not only would you have to do a Punnett square for the two different alkenes, you'd have to do a Punnett square for the alkenes with themselves, and then the products themselves would begin to react, so you would actually have to start going through all the different iterations of the different ways you could combine these two fragments. So very much on the hard end, not something you would typically see on an exam, but definitely a good way of kind of like stretching your, just kind of stretching your approach with organic chemistry and seeing like the complications and variety you do get with metathesis. Now again, something simple like ring opening, ring closing metathesis, or where one of them is being run in high excess, particularly it's ethylene, those don't require Punnett squares because they're much simpler examples, and that's typically what we see done in industry anyway, because something like this would just be a witch's brew of constitutional isomers that would require a ton of separation for very little of the product we're actually trying to isolate.